My name is Álvaro Muñoz. I'm also known as a Point Tester. I'm Principal Security Researcher with HP Fortify team. And here with me, my colleague Alexander Miros, which is also Security Researcher with the HP Fortify team. So we have a packed agenda for today, so let's jump straight in. 2016, last year, was the year of Java deserialization attacks, right? It was a very well-known vector since 2011, but probably because of the lack of remote code execution gadgets in very popular libraries, this vulnerability kind of got ignored by the community, and no one was actually looking for it until last year. So this is also true for the .NET deserialization. It's a very well-known vector, at least for the binary formatter and for the net data contract serializer, because it was presented like 4 years ago here in this same conference by James Forso. But since there was no remote code execution gadgets, again, the community is not actually looking for these vulnerabilities or kind of ignoring them. So at that time, the solution was like, okay, stop using Java deserialization altogether. It's dangerous. You should not deserialize untrusted data. And developers were like, well, yeah, I would like to do so, but I need to store my objects into this database, or I need to move or send these objects across the wire, so I need to use something. And then the security experts were like, okay, then use something like a secure JSON or XML library instead. So our goal with this talk is twofold. First of all, we want to verify if those JSON libraries are any better than the Java deserializer, like the object input stream, and also raise awareness around the .NET deserialization vulnerabilities. We will be providing a list of vulnerable libraries and gadgets. So in the first section, we will cover JSON libraries for both .NET and Java. We will provide gadgets leading to arbitrary code execution, and then we will have some demos showing how to get arbitrary code execution on web application frameworks. And then the second block is about .NET serializers. We want to raise this awareness, and we will provide gadgets leading to remote code execution gadgets, and again, we will show you some demos. So with any further ado, let's jump into the JSON section. And just to set the expectations clear, we're not talking about JSON when used to exchange simple data or simple JavaScript objects between the front end, like a JavaScript front end, and maybe, I don't know, a Spring controller in the back end or something like that. We're talking about replacing Java deserialization and .NET deserialization with JSON libraries, which means that you need to serialize Java objects and .NET objects. And in order to do so, you need to deal with object-oriented programming features like how I'm going to serialize a Java-lang object, or how I'm going to serialize a system object in .NET, how I'm going to deal with generics, how I'm going to deal with interface fields, polymorphism, and so on. So a very quick recap on how attackers were able to get arbitrary code execution with Java deserialization attacks. Basically, they were sending like a stream of untrusted data to the deserializer, to the vulnerable endpoint. And this data contain some type discriminators that is nothing else than the class name for these, for some types, some arbitrary types that the attacker could control. Then the deserializer were basically instantiating these types and then invoking some deserialization callbacks on these types, right? So basically, the attacker needed to find a type or a class containing a read object or read resolve method, which could be chained together with other types or classes in order to assemble a gadget chain leading to arbitrary code execution. However, JSON libraries don't normally invoke any deserialization callbacks, so we need to start these gadget chains in a different way. So let's see how these JSON libraries reconstruct the objects when deserializing, and see if we can take benefit of some of these methods in order to start our gadget chain. So normally these libraries, it depends on the library because every library is different from the others, but normally they will invoke the default constructor, which is not very useful for the attackers because it takes no parameters, and then they will use either reflection or calling setters in order to set the values of the fields or the properties of the class. Some of the libraries will invoke some deserialization callbacks or special constructors. Some of them will call type converters. That is a .NET specific type, which we don't have time to cover in this talk, but it's included in our white paper that will be published today, I think. So let's just make sure that you check it out. And then most of the libraries will also invoke some common methods. Like for example, when dealing with hash tables, hash code or equals may get invoked. ToString may get invoked when raising an exception, if you can force the library to raise an exception. Finalize is always invoked by the garbage collector when claiming the memory. So we can actually start our gadget chains using some of these libraries. By far, the most common one used by all these JSON libraries is the setters. Most of the libraries, if not all of them, will invoke setters. So what we did is research and look for gadgets starting with setters, leading to arbitrary code execution both in Java and .NET.
Let's have a look on a few gadgets in .NET. All of them can lead to arbitrary code execution. Some of them has own requirements or limitation, but we believe so that it's not very difficult to pick up proper one for specific library. So our first gadget is setter of path property in assembly installer class. It allows code execution during library loading from paths controlled by an attacker. There is no additional requirements in case if assembly with payload is on local machine, but if we try to provide remote resources, .NET framework may have some additional security checks. The next two gadgets use a XAML parser. We will show a bit later how it can be used for arbitrary method invocation. So, property inspector font and color data in workflow designer type requires single threaded apartment thread. It's quite strong requirement, but if your target has such configuration, you will get remote code execution. The next gadget is source setter in resource dictionary. It has a few requirements to JSON and marshallers. They should call setters for types that implement iDictionary interface. Often in such case, unmarshallers are just populating key value pairs. Also, they should be able to reconstruct system URI type. This type does not have a default constructor, but very often parser can do this. And finally, our gadget in object data provider type. It's quite flexible and allows us to use a lot of vector attacks. So as a result, we were able to use this gadget in almost all our unmarshallers and formatters. Let's have a look on it closer. So it's a call diagram. Setter will call refresh method. Refresh method will invoke begin query. Begin query will call query worker. And finally, in invoke method on instance, we can see line that will call our arbitrary method. Here we can see an example of JSON payload that will pop up calculator in JSON.NET parser. This gadget offers us the next way for attack. We can call non-default constructor with own parameters. We can invoke a method on unmarshalled object, or we can call any public method including instant and static ones with our own parameters. Java has its own setter gadget as well. After our last year research on GNDI injection attacks, we have found a few setters that call GND lookup method. By the way, Oracle recently disabled RMI and Corba vectors in default configuration of Java, but LDAP vector still works. So set session factory GNDI name in statistic service class. We already mentioned about this in our talk at Black Hat 2016. Very similar to it is a ToString gadget from remote client user transaction class. And finally, set auto commit from already known JDBC row set impl class. Let's have a closer look on it. It is from GRE libraries, so we don't need any additional dependencies. As we can see on this slide, setter will call connect function. And here we will call initial context lookup method with our value from data source name property. So we will get a remote code execution. Apart from mentioning the gadget that allow code execution by themselves, we have a few other interesting gadgets. Some of them can be used as building blocks for gadget chains, like string template to string in Java, or binding source set data member in .NET can be used for arbitrary getter call. Other can trigger non-remote code execution attack, like inner XML in XML data document type, or data view setting collection string in data view manager type. Can be used for external XML entities attack in some version of the .NET framework. Now we will switch back to Alvaro. He will show where we can use all these gadgets.
So we analyzed a set of different JSON libraries, both for Java and .NET, and we were able to get arbitrary code execution in most of them, as long as they meet these three simple requirements. So the first one is that the attacker needs to be able to control the type, the class name that is going to be reconstructed at the serialization type. So normally that means that the JSON will contain something, some attribute like this underscore type, $type, class name, or something like that, that contains a value that looks like Java class name with a namespace, or something like a .NET assembly or something like that. And then the library is going to instantiate that type. The second requirement is that the library needs to invoke any method. Normally it will invoke setters, but we saw before that it can invoke some other methods. And the third requirement is that the attacker needs to be able to find large enough gadget space for him to craft or assembly a gadget chain leading to arbitrary code execution. So we categorize all the libraries that we analyzed according to this categorization that is basically based on two different factors. The first one is whether these libraries include the format or the type discriminator by default or not. For example, in this case, you can see here that this is JSON.NET library and contains this $type with something that looks like a .NET namespace. And then the second factor is how they control which classes or which types are going to be instantiated during deserialization. Some libraries perform just a post-deserialization cast operation, which is basically offers no protection at all, because by the time that you get the cast exception, the deserialization has completed and the payload has been executed, so you are already in trouble. And the other type control that most of the libraries do is perform what we call the inspection of the expected type object graph, which looks like a little bit complex, but is actually very simple. The library will check what is the expected type. So for example, the library may be expecting a user type, and then it will recursively analyze the object graph, and when deserializing from the JSON data, it will check if the expected type is assignable from what the attacker or what the user is sending. So for example, if the user or the library expects a string, if we provide something like an object data provider that is our gadget, then the library will throw an exception and will fail to deserialize the data. Some other libraries, in addition to this assignability check, will also build a whitelist during construction time. So at runtime, when deserializing, they will apply this whitelist, and only those types that appear in the object graph at construction time will be allowed to be deserialized. We found that these libraries are still vulnerable if the attacker can control the expected type, which is more common than you may think, and we will see an example later, or if the attacker can find an entry point in this object graph. So for example, in this simple object graph, all the elements in red are entry points that the attacker can actually use to place their payload. So that may be, for example, a system.object type, or a non-generic collection like a hash table or a array list. So in our paper, we have like a more detailed explanation of how to find these entry points in the object graph. So this is the list of the libraries that we analyzed. As you can see, we have some of them that are .NET and some of them are Java. We included the most popular ones like the JSON.NET for .NET and the Jackson, probably the most common or most popular one for Java. The ones in red are those that are vulnerable by default, out of the box. No matter what you do, you cannot protect them and make them safe. For example, fast JSON, swift JSON, JSON.io, or flex JSON, because they include the type discriminators or type names in the serialized data, and because they perform no type control at all, except for this post-deserialization cast operation, they will always be vulnerable because they invoke as setters, and then we will be able to use our setter gadgets to get arbitrary code execution. The one in yellow depends on how the developers configure the library in order to, for the attacker to be able to get arbitrary code execution or not. So by default, normally they don't include the type information in the data, and they perform an inspection of the expected object graph. And you may think that these two requirements are hard to meet at the same time or to find in a real application, but it's actually the opposite, because if developers are serializing something that contains, or an object graph that contains, for example, a system.object or a Java lang object, they will need to enable these configuration settings to include the type information, because otherwise they won't be able to serialize that data. The one in green, JSON, is actually the one that we consider secure, because there is one way of making it insecure, but I mean, you need to be able or want to make it vulnerable in purpose, because it's very difficult. And in addition, as you can see here, it invokes no setters at all. It uses reflection, so you cannot use our setter gadgets. You need to find new gadgets, for example, in finalize methods or other methods that may get invoked in JSON. So we consider it as kind of a secure library. So let's see some of these libraries. For example, FastJSON was one in the red category. They always include the type discriminators. They perform no type control at all. So if you find an application using FastJSON with untrusted data, you will be able to get arbitrary code execution. And that's what we found, for example, in this Calico content management system that was deserializing untrusted data, leading to arbitrary code execution. Then we have JavaScript serializer, that is one of the .NET native serializers. By default, it's secure because it does not include the type information, so it's good. But when calling the constructor, as you can see here, developers can pass a type resolver. If they do that, this type information will be included in the serialized JSON data and will be processed when deserializing the data, so that will make the library vulnerable, because this library performs no type control at all, just this post-deserialization cast operation. So again, these libraries can be used securely with untrusted data as long as you don't use any type resolver. Then we have data contract JSON serializer, that is a different .NET native JSON serializer. Well, this is probably one of the most secure JSON serializer that we've seen. It performs a expected type object graph inspection, but it also builds this whitelist at construction time that is applied at runtime. So finding an entry point is not an option for this library. And the other way that you can attack it and get arbitrary code execution is if you can control the expected type. You may think that something like this, that the expected type comes from a cookie and then is used to initialize the serializer, is nothing common, but we will show you a demo on a very common or very popular content management system in .NET that does exactly that. Then we have JSON.NET, that is probably the most popular JSON serializer for .NET. By default, it's secure because it does not include type information. But again, developers can enable this type name handling setting, which will make the library include the type discriminators or type information in the JSON serialized data. So this is another example. By the way, all these examples are from GitHub, so this is real code. In this case, the type that is going to be serialized, that is message, contains this body property, which is system object. So because of that, as I said before, developers will be forced to enable this type name handling setting that will force the library to include the type information, because otherwise, at deserialization type, it won't know to which type deserialize that data. So this library will invoke setters, iserializable constructor, callbacks, even some custom callbacks, type converters, so you can use a very broad set of gadgets to get arbitrary code execution for JSON.NET. Okay, so let's see one example of an application, or in this case, a framework that is using JSON.NET in an insecure way, so we were able to get arbitrary code execution. So this is Breeze. This is a data management framework, which basically exposes a REST API for both JavaScript and .NET clients to connect and perform like entity management operations, like adding new records, deleting records, updating records, and so on. It's kind of popular in the .NET world. And if we look at the source code, we will see that they use JSON.NET as the global serializer. This JSON.NET is configured to use this type name handling object, which means that when serializing system object properties, they will include the type information. Now, if we check the source code, we will see that at some point, the JSON.NET serializer is used to deserialize untrusted data, and the expected type, in this case, is safe option. If we perform this inspection of the expected type object graph that looks like very complex, but it's nothing else than looking at the expected type object graph, in this case very simple, and we can see that it contains a tag property that is system object. So we will be able to place our payload in this property and get arbitrary code execution. So let's see that in action. This is one of the sample applications that comes with Breeze. It's a sample application that lets you update or create new car models, just something simple to teach developers. So if we send like this change for the car model name, we will see that in our request we have the change of the model name, like Mustang 2, and then an empty dictionary that is called safe options. If we send this request, in the response, we will see this $type attribute with something that looks like a JSON.NET serialized type. So this is a good indicator that this application is vulnerable. So now we're going to use our object data provider setter gadget in order to call the process.start method and pop up a calculator. So we will copy and replace this empty safe options dictionary with our payload. And if we send it, well, let's check that the victim server is not running the calculator, of course. If we send it, we will get our calculator. Thank you. So we wanted to give a shout out to Maurice Bechler, that is a recognized Java security researcher. He published similar research on May 22, after our research was finished and published and accepted for Black Hat and DEF CON. But he shares the same kind of premises and conclusions. He focused exclusively on Java, and he overlaps with our research in both the Jackson and JSON.io libraries, although for the JSON.io he found a completely different vector. And he also overlaps with us in this JDBC rowset impl gadget that was kind of an obvious choice because it was previously used in the Java deserialization world. But he also found a very interesting gadget in Spring libraries and other libraries. So if you are more interested in the Java version of this talk, let's go and check his research. And now Alex will switch gears and move into the .NET section.
Let's back to the .NET world. Potential security problems in binary formatter and net data contract serializer were known for the years. For example, great work of James Forshaw about weaknesses and main attack vectors in .NET formatters was presented at Black Hat 2012, so 5 years ago. Anyway, we could not find a good remote code execution gadget chain. There was one published by Florian Gaultier, but it uses memory corruption, so it's quite difficult to build a universal exploit for different versions of Windows. But we were sure that there should be a lot of ways to get code execution during .NET deserialization. So we spent some our time for searching such gadget and have found one that can be used in binary formatter or some other .NET formatters. But after our work was ready and talk was accepted by Black Hat, the same James Forshaw published a couple remote code execution gadget for binary formatter as his own, as part of his own research. By the way, not connecting with JSON or our talks. Anyway, you can find details about this gadget on his post on Google Project Zero blog. Here we will focus on our own. We will use PS object type. This type is from PowerShell libraries, so is available on almost all Windows machine. Before we go further, there are a couple of remarks about this gadget. In first version of PowerShell, this type is not serializable, so is not suitable for attack. But all modern version of Windows, starting from Windows 8 and Windows Server 2012, are shipped with newer and vulnerable version. Also, if you updated your PowerShell on older Windows version, this problem is relevant for you as well. Next remark, we reported this problem to Microsoft, and 2 weeks ago they released a fix. So if you are not ignoring their updates, you are safe. So PS object, it uses custom deserializer, and in case of TIM instance, it will call TIM instance, reiterate TIM instance property. Here we can see that attacker is able to specify own type as element type of array, and the serializer will try to deconstruct object of this type. For finding proper way to do this, it will use a figure conversion method. It's quite interesting for attacker as there are a lot of options to attack. We highlighted only the most obvious one. We can call a non-default constructor with one argument, and we can control this argument. We can invoke setters on public properties, so we can use mentioned earlier gadgets, or we can call static public parse method of arbitrary type. Let's try to use this one. As we said earlier, XAML reader parse can be used for arbitrary method invocation. Here we can see a payload that will call process start with our argument. We can notice namespace, assembly, type, method name, and finally calc as our argument. Apart from already mentioned binary formatter and net data contract serializer, .NET offers a lot of other formatters. Unfortunately, we don't have enough time to cover provide a detailed review of each of them. So we will briefly cover them in today's talk. And if you are interested in deeper analysis, we can offer our white paper as good source. So we can group them in 2 big groups. Formatters that are vulnerable in default configuration, like binary formatter, SOAP formatter, net data contract serializer. Also, we can add here formatters that internally use them, like object state formatter, loss formatter, binary message formatter. They should not be used for the serialization of untrusted data, or you have to proper configure them to limit available types. For example, use restricted type resolver with whitelisted types. The second group is formatters that are safe in default configuration, like XML serializer, data contract serializer, and data contract JSON serializer. But if you are using a weak data contractor resolver, by the way, we have found such examples even in official Microsoft documentation, or attacker is able to control expected type, you have a very serious security problem. And we will show a bit later how that in this case, code execution is real even for the most limited formatters, like, for example, XML serializer. Now we will switch back to Alvaro, and he will show our next demo.
So because demo is probably worth 1,000 slides, let's see how can we use our PS object gadget to get remote code execution on any application built using this Nancy framework. So for those of you that are not familiar with Nancy, it's a web application framework for the .NET world that is very similar or inspired by the Ruby Sinatra framework. They offer some security features, like for example, sysarf protection, which is good. But in order to protect against sysarf, they open the doors to remote code execution, which is not that good. In this case, what they were doing were basically setting this unique value that we use to protect against sysarf. Instead of putting that value directly into the cookie, they were putting that as the property of a class and then serializing that class into the cookie and then sending the cookie over the wire. So we were able to get pre-authenticated remote code execution on any application built using Nancy. And let's see, well, this is actually the payload that is base64 encoded. If you find this AAEAAD magic number in any of your pen tests, then you get remote code execution. So this is a sample application that we built using Nancy, very simple. If we check the cookies for this application that this application is setting in our browser, we will see this nsysarf cookie, which contains this magic number. So we were like, oh, this is code execution, nice. Now, if we check the source code, we can see that this same value is also included as a hidden field for this form. So this is making this kind of double submission of the sysarf cookie. Now we will be using our PS object gadget. Now, because it's fixed by Microsoft, you can use any of the James Forso gadgets instead, so they will work as well as ours. And if we replace the cookie with our PS object gadget that is configured to pop up a calculator and we just submit the form, we can see that there is no calculator again. And if we send and submit the request, we will get a 505 exception, but no problem because we got our calculators running. Thank you. So we wanted to highlight that this is not a problem in JSON. This is not a problem in XML or, for example, in Java deserialization or binary formatter for .NET. This is actually something that is a problem in serializers themselves. So most, or if not all of the serializers will need to reconstruct those objects during deserialization. And if you find that these serializers are satisfying these three requirements that we mentioned before, so including type information in the serialized data, invoking methods on those reconstructed objects, and then with some large enough gadget space for the attackers to assembly gadget chains leading to arbitrary code execution, then you will be able to attack any format in any language that you will find. Also, because most of the libraries will invoke setters, the gadgets that we presented here today, Object Data Provider and the JDBC row set impl, can be used to attack most of the serializers out there that satisfy these requirements. So we found many, we reviewed many formats, and we found many of them vulnerables. We want to highlight these three because, well, we don't have time for more. For example, fspickler and SARP serializers are .NET serializers that work not just with the .NET framework, but also with .NET Core, Silverlight, Windows Mobile Phone. So developers may choose these serializers over the native ones when working, for example, in Silverlight or whatever. So both of them include type information by default. Both of them invoke setters, and well, fspickler performs an inspection of the object graph inspection of expected type object graph. But so you will need to find the entry points. But self-serializer performs no type control at all, which means that it cannot be used with untrusted data at all. Then we have Wire, that is now known as Hyperion, and is the serializer for Akka.NET. Akka.NET is basically the .NET version of the famous Scala and Java framework to deal with concurrency using these actor-based models, which basically these actors communicate exchanging messages that are serialized with JSON.NET using the insecure configuration that we showed you before, this type name handling equals all. However, you can enable this new custom serializer that they implemented that is called Hyperion, that also includes type discriminators, also invokes setters, and also performs no type control at all. So if you can send a message to an Akka.NET or Akka actor, you will be able to get remote code execution as well. Also, beware of rolling your own format. This is like crypto, right? For example, Nancy, the framework that we saw before, they decided to move away from binary formatter because binary formatter was not going to be included in the first version of .NET Core. So they implemented their own JSON parser. So what can go wrong? Well, they included this type object discriminator, so attacker can control the type, and they invoke setters. So we were also able to get arbitrary code execution in this pre-released 2.x version. Well, it was released as a beta, but it was not like the official version. And then we also found one of the most popular CMS for the .NET world that is called the .NET Nuke, DNN, or if not the most popular library, which uses XML serializer to serialize untrusted data. And in this case, for example, the value in a request cookie. Well, they wanted to use XML serializer with arbitrary types. So in order to do that, they created this wrapper around XML serializer. So they send the type that is going to be like the expected type, and then the payload for the XML serializer. XML serializer is the most limited by far serializer in the .NET family. So it was like a challenge for us. If we were able to get arbitrary code execution in this case, we were sure that we can do that for any other libraries. So we wanted to use our object data provider gadget. And well, that's so far so good because it's XML serializer friendly. It can be serialized by XML serializer, no problem at all. However, if we want to invoke process.start, then we'll get our first problem because process contains interface member. And for example, XML serializer is very limited. As I said, it cannot serialize types with interface members. It cannot serialize types with system.type properties, for example, and many other limitations. So we couldn't use the process.start as the final gadget. However, this was easily solved because we can use our SAML reader load gadget or the object state formatter deserialize in order to get remote code execution, or even better, you can actually search the target application class path for interesting gadgets. And the guys at .NET Nuke were kind enough to provide us with this file system utils class that contains methods that are very convenient to deploy web cells or to read files and put the response the data into the HTTP response. So that problem was solved, no problems so far. Now, when XML serializer builds one of these whitelists that we talked about before, so at construction type, it will see that the object data provider contains a system.object property. So it will include system.object as in the whitelist, but at runtime, we will be providing something else. We will be providing the SAML reader, or maybe the file system utils, or maybe this object state formatter, something else, right? So these types won't be in the whitelist, and so the XML serializer will prevent the deserialization of these types. So we needed to fool XML serializer into including these types into the whitelist. And the way we did it was basically using this expected type, which is basically a parameterized type. And in the parameterized type, we're placing our runtime types. So these are going to be included in the whitelist, and when we send our payload, it will work like a charm. So let's see that in action. As we said, we were able to get arbitrary code execution pre-authentication on any instance of the .NET Nuke CMS. And well, this is the source code leading to the vulnerability. The source is in this piece of code that gets executed, for example, in many cases, but one of the cases is when visiting the 404 page, the error page. So at that time, this DNN personalization cookie is going to be read and then passed to this deserialized hash table XML method. Then here, we'll basically extract the type from the XML cookie and then use that type to build our XML serializer. So the attacker can control the expected type. Remember that I told you that this is more common than you may think? Here's an example. And then it is deserializing the rest of the cookie. So this is how a regular cookie looks like. It contains the expected type, and then this blue box here is the payload for the XML serializer. And this is how our payload looks like, a little bit different. So here the expected type is this parameterized type, and here we are telling XML serializer to include these types into the whitelist. Then we will use this file system utils class to download our web cell, deploy it in the IIS root directory, and we will be able to deploy our web cell. So let's see a video of that. So this is the out-of-the-box installation of DNN. If we visit a non-existing page, we will get our 404 error page that will force the processing of the DNN personalization cookie. So we will send this page, this request to Burp. We will capture it, and because it's by default it's not including this cookie, even if it's processing the cookie, it's not including it. We will include it. We will write here our DNN personalization cookie, and then we will paste the XML payload that I just showed you. Basically, it's invoking the pull file method of the file system utils class to download our web cell and deploy it in the victim server. So let's format this a little bit. Now, if we go to the victim server, we will check that the cell ASPX file that we are going to download is not existing here. If we send the request, it will be downloaded, and we will get the cell available for the attacker to interact with the system. So at this point, the attacker can just use the web shell, as I said, to interact with the system, install Meterpreter or whatever they want to use. Thank you. And just to wrap up, as I said before, this is not a problem in JSON or XML or Java deserialization. This is a problem in serializers themselves. So try to avoid deserializing untrusted data with any formatter, even if you think it's secure. But if you have to, try to get that library evaluated from a security point of view by your security expert of choice. And try avoiding libraries that performs no type control, like the ones that we saw that are just doing a post-deserialization cast. Also try to avoid those libraries that are including type information in the serialized data, because that's not sufficient to get arbitrary code execution, but it's a good indicator that it may lead to arbitrary code execution. Also, don't let the users control the expected type of any deserializer, because they will be able to control the object graph inspection, and they will be able to place anything there. And last but not least, try to not roll your own format if you don't know what you're doing. So with that, thank you very much. It was a pleasure. And if you have any questions, I think we have like 5 minutes. 5 minutes, questions. Please go to the mics, I think, in the aisles. No questions. Oh, also, we will be publishing the white paper. It will be published today in the Black Hat site, so just make sure that you check it out. It contains a lot of information and details. Okay, so thank you very much.